Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 2nd, 2026, just 5 days ago. It introduces a massive framework that constructs over 800,000 real-world software engineering environments, helping a model named QN3 Max Thinking achieve a state-of-the-art score of 75.3% on SWE-Bench verified. The paper is titled SWE-Universe, Scale Real-World Verifiable Environments to Millions. And as we'll see later, the implications for training future coding agents are really quite profound. To visualize just how dramatic this expansion is, Figure 1 compares the instance counts across major software engineering datasets. On the left, established benchmarks like SWE-Bench and Nemo v2 Flash range from about 2,000 up to 90,000 examples. In contrast, the massive orange bar on the right shows SWE-Universe exploding past them, with nearly 808,000 multilingual instances. This order of magnitude leap really highlights the data advantage this new framework provides. Well, Figure 2 breaks down the machinery behind that advantage, detailing the framework's pipeline. At the core sits a building and verifier agent, which takes a raw pull request and iteratively attempts to create a robust evaluation script. To keep the quality high, the hacking detector on the bottom left monitors the agent's output, blocking lazy shortcuts like simple string matching. Meanwhile, the verifier validation module on the right ensures correctness by running the script against both the buggy and resolved code states. This rigorous process guarantees that the final software engineering task is both executable and valid. So, Figure 3 illustrates exactly what counts as a valid verification script versus a lazy shortcut. The first two panels show acceptable methods. The left one executes existing human-written unit tests using standard tools like Jest, while the middle one shows the model writing its own Python script to dynamically test the code. However, the panel on the right demonstrates the hacking behavior that the system rejects. Instead of running the program, the agent simply uses grep to check if certain strings exist in the file, which doesn't prove the code actually works. Alright, following that discussion on strict verification, Figure 4 plots the trade-off between dataset size and task quality. The vertical axis represents the number of instances on a log scale, while the horizontal axis measures the quality score. SWE-Bench verified sits in the bottom right, achieving the highest quality, but covering only a small number of samples. In contrast, SWE-Universe dominates the upper region, providing a massive volume of data that significantly exceeds smaller datasets like SWE-Bench, even with a moderate quality score. Well, Table 1 benchmarks the success rates for automated environment building across different foundation models. The author's custom model, QN-Next80A3, claims the top row with a 78.4% success rate when excluding hacked solutions. It narrowly beats out proprietary giants like Claude Opus 4.5 and Sonnet 4. The columns on the right further reveal that this performance holds up across multiple languages, including C++ and Java, ensuring robust support beyond just Python. Moving on from success rates, Table 2 details the massive scale and linguistic diversity of the final dataset. It breaks down the total count of nearly 808,000 instances, which were harvested from about 53,000 unique repositories. Python naturally leads with over 200,000 examples, while JavaScript and TypeScript follow closely behind. Crucially, the middle rows highlight significant coverage for compiled languages like Go, Java, and Rust, proving that the framework successfully generalizes well beyond just Python scripts. Okay, Figure 5 demonstrates the practical payoff of training on this massive dataset. On the left, Panel A tracks performance during mid-training, where we see a clear upward trend on both the verified and multilingual SWE benchmarks as the token count grows to 70 billion. Then on the right, Panel B shifts to reinforcement learning results. The curve shows the model improving steadily over training steps, eventually hitting a peak score of 42% on the multilingual task. So, wrapping things up, this paper demonstrates that the real bottleneck for coding agents is scalable, high-quality data. By automating strict verification for over 800,000 instances, SWE-Universe proves that we can train models to handle complex, multilingual software tasks with state-of-the-art reliability. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.